Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers percentages. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 4. Circle the calculation that increases 50 by 200%. Now this is a percentage increase, which means we're already starting with 100%. So if I'm going to increase it by 200%, then I'm going to use a multiplier of 100% plus 200%, which is 300%, which is 3 as a multiplier. So it's going to be 50 times 3. Question 1. Circle the multiplier that reduces a quantity by 12.5%. Okay, well if you start with 100% and you reduce it by 12.5%, you're going to be left with 87.5%, which as a decimal is 0.875. So that's our multiplier there. Question 2. What is 50 as a percentage of 20? So if you get 50 out of 20, I love maths, everything is possible, and times it by 100, you'll get 250%. Question 4. Work out 40 as a percentage of 10. Circle your answer. Okay, so we want 40 as a percentage of 10. In other words, 40 over tenths is a fraction. So if I want to turn a fraction over 10 into a percentage, I need to change the denominator to 100, which I can do by multiplying by 10. But if I do that to the denominator, I have to do it to the numerator as well. So my 40 over 10 is the same as the fraction of 400 over 100. And any fraction over 100 is the same as that as a percentage, isn't it? So that is 400%. It's going to be that one there. A ball is dropped from a height of 50 meters. After each bounce, the ball reaches 20% of its previous height. How high does it reach after the second bounce? Okay, so after the first bounce, it is going to reach a height of 20% of its original height of 50. So 50 times 0.2. What's that? So 50 times 0.2 is the same thing as 5 times 2, which is 10. So it's going to reach a height of 10 meters after its first bounce. And then after its second bounce, it's going to reach a height of 10 times 0.2. 10 times 0.2 is 2 meters. So the answer is 2 meters. A doctor claims that the probability of having regular illness is doubled if you have poor sleep rather than good sleep. In a survey, 16% of people with poor sleep had regular illness. Here are the results for people with good sleep. Comment on the doctor's claim. You must show you're working. Okay, so we need to work out what percentage of these people had illness. So if I had 24 people with regular illness and 276 with not regular illness, then adding those two numbers together will give me the total of the sample size. I'll just change pen. So 300 altogether. So I've got 300 people. So then what is 24 out of 300 as a percentage? Well, a percentage is a fraction over 100, which means I need to divide that by 3, so I need to divide that by 3 as well. So 3's into 24 go 8 times, so that as a percentage is 8%. Okay, so it looks like the data here does support the doctor's finding, because here 8% of the people with good sleep had regular illness, whereas 16 people had 16% of the people with poor sleep had regular illness. So I'm going to write underneath then that the doctor was correct, as 8% of good sleepers had regular illness, compared to 16% of, what do they call them? Poor sleepers. Yeah. Which is twice as much. Question 20. Here is a diagram of a pack of cereal. Lovely flakes. 360 grams, 12 servings, 79 grams of carbohydrates per 100 grams of flakes. Eve has a daily allowance of 260 grams of carbohydrates. She says, one serving gives me more than 9% of my daily allowance. Is she correct? We must show our working. Okay, so let's break this down then. So 360 grams is 12 servings. So let's take that first piece of information first off. So if there are 360 grams in 12 servings, then one serving is going to be 360 divided by 12, which is 30. So there's 30 grams in one serving. Now there are 79 grams of carbohydrates per 100 grams of flakes. Well, she's not got 100 grams, she's got 30 grams. So carbohydrates in one serving is going to be 30 divided by 100 lots of 79. So that's 23.7. So it's 23.7 grams of carbohydrates in her single serving. So finally, we're told that her daily allowance is 260 grams of carbohydrates. So we want to work out what 23.7 grams is as a percentage of 260. So percentage of daily allowance is going to be 23.7 divided by 260, which is 23.7 divided by 260. That's 0.091. So it's slightly more than 9%, isn't it? That's 9.11%. So she says one serving gives more than 9% of my daily allowance. Well, she's absolutely correct. Eve is correct. Question 11. Billy wants to buy these tickets for a show. 4 adult tickets costing £15 each and 2 child tickets costing £10 each. A 10% booking fee is added to the ticket price. 3% is then added for paying by credit card. Work out the total charge for these tickets when paying by credit card. Okay, so first off, how much is the total amount to be paid? So cost of tickets. It's going to be my 4 adult tickets at £15 each, plus my 2 child tickets at £10 each. 4 15s are 60, 2 10s are 20. Adding those together gives me 80. So the cost of the tickets is £80. Plus we need to put on the booking fee. Booking fee is going to be It's going to be 10% of that, so that's going to be £8, isn't it? Give me a total of 88. And then finally, I need to add 3% for paying by a credit card. Okay, so I've got £88. What's 3% of £88? So this is my credit card fee. So if I have £88, then 10% is £8.80 and 1% would be 88p. So 3% is going to be 3 lots of 88 pence. So what's that? 24, 240 and 3/8. 264. £2.64. So then the total amount payable then is going to be my £88 plus my £2.64. So total could be 88 plus £2.64, which is £90.64. Question 6. The table shows information about the population of a city. And we can see the population in 2001 was 420,000 and the population in 2011, it's gone up. It's now 480,000. Okay, Liam claims from 2011 to 2021, the population of the city will increase by the same percentage as from 2001 to 2011. He works out the population increase from 2001 to 2011 is 480 subtract 420, which is 60,000. So the population in 2021 should be 480 plus 60, which is 540. Does the population of 540 match his claim? You must show your working. Okay, so he has said here that from 2011 to 2021, the population of the city will increase by the same percentage as from 2001 to 2011, but he hasn't actually worked out what that percentage is. All he's done is subtracted one number from the other, so he's found the difference between those two numbers is 60, and he's added that same difference onto the population in 2011 to estimate what it will be in 2021. But that is not the same percentage. 60,000 as a percentage of the population in 2011, 60,000 over 420 is not the same percentage as 60,000 over 480. Okay, so we need to put that down somehow. So does the population of 540 match his claim? Okay, so first off, let's see if we can work out the percentage increase, or the percentage change I should say. Percentage change from 2001 to 2011. What's that equal to? Okay, well if you use the triangle that I often use in these problems, final original multiplier, Percentage change, we want the percentage, which is kind of like the multiplier part. So we need to use final is equal to, sorry, multiplier is equal to final over original. So let's write that down as a formula. Multiplier is equal to final over original. Okay, so the final amount was 480. That's the amount in 2011, 480,000. And in 2001, the original was 420,000. So tapping that into a calculator, 480,000 divide by 420,000. That's 8 over 7. That's not very helpful. That's 1.1428. So I'm going to write that. I'm just going to round it off to. Just going to round that off to 1.143. Okay, so that is as a multiplier. So it's a percentage. That is 114.3%. So that means the percentage increase is 14.3%. Okay, now let's work out the percentage change from the next amount if it was going up in 60,000 again. So kind of run out of space here. So the percentage change from 2011 to 2021, again, our multiplier is going to be equal to our final over our original, which is equal to, well, what did he say it was? 540,000 divided by what it was in 2011, which was 480,000. Okay, and then dividing one of those by the other in my calculator. So I'm just going to type in 540 divided by 480 because that's going to give me the same number. I'm getting 1.125 now. So that's 1.125 as a multiplier, which is 112.5%. Okay, so that is an increase. I should have written increase over there. 14.3 increase there, and here it is a 12.5% increase. So they are different percentage increases. So what's the answer? Does the population of 540 match his claim? No. And we've got 14.3% and 12.5%. So our two percentages. Okay. There seems to be enough space there to do all the method, or maybe I'm just not using it well. Okay, let's move on. In question 9, we're told that a school has 60% of their students being girls, and of those, 50% of the girls walk to school and 20% of the boys walk to school. What is the percentage of students who walk to school? Now, first thing to note in this question that there's no number of students given, so we're just working purely with percentages. If it makes it easier for you to think about, then you can just assume that there are 100 students. So assume 100 students. Okay, now I'm going to try and collect all this information in a two-way table because we've got two quantities. We've got boys, girls, walk to school, doesn't walk to school. So I'm going to make a two-way table, a bit like this. So this is going to be my boys, girls, walk to school, doesn't walk to school. Now I know that altogether we've assumed there are 100 students. I'm going to write that down there in the bottom right corner. Now we are told that 60% of the students are girls. So that means the total number of students that are girls are 60, and that means there must be 40 boys or 40% boys. Now, next we're told that 50% of the girls walk to school. 50% of the girls walk to school. So there are 60 girls altogether. So 50% or half of them walk. So that's going to be 30 there. So if 30 walk and there are 60 altogether, 30 don't walk. Okay, and then for the boys, 20% of the boys walk to school. So we decided there were 40 boys. 10% of 40 is 4, so 20% is 8. So we're going to have an 8 there. So that makes this one 32. Okay, so adding up along the columns now, I know that 38 out of 100 walk and 62 out of 100 don't walk. So what percentage of students walk to school? It's going to be 38 out of 100 or 38%. 11b. A voucher takes 15% off the bill. After using the voucher, the bill for a meal is £27.20. How much was the bill before the voucher? Okay, so I teach my students how to do percentage questions using this triangle, FOM. I tell them to put their thumb on it and work out which is which. So F stands for final, O stands for original, M stands for multiplier. So I asked them to identify each of these three things. So a voucher takes 15% off the bill. So the multiplier then, if you've got 100% and you're doing a 15% deduction, that is going to leave you with 85%, giving you a multiplier of 0.85. Okay, after using the voucher, so that bit of information is there. So after using the voucher, the bill for the meal is £27.20. Now you need to use your past, present, future tense to work out which is which often with these sorts of questions. So after using the voucher, the meal is £27.20. So that we've been given is the final amount. Okay, so the final amount is £27.20. Okay, so the original amount before the deduction is the one we don't know and the one we want to find. Yeah, there it is, before. So that's got to be the original price. So what this method does is says is you cover up the one you want to find, which is that one, and it's a bit like the distance, speed, time triangle that you can use the triangle to work out what to do with the other numbers. So I'm going to be using the formula original equals final over multiplier, and that is equal to £27.20 divided by a multiplier of 0.85. We actually call this sort of problem a reverse percentage question because we are working backwards, aren't we? We know the final price and we want the original. But if you follow the method that I'm using, you just really need to be clear in your own head which is which. That gives me the answer on my calculator of 32. So the original price then was going to be £32. Okay. You can actually use this FOM triangle for any percentage question, and if you check out some of my other videos, you'll see how I apply it to all sorts of percentage questions. So, question 9. The cost of a ticket increases by 10% to £19.25. Work out the original cost. Okay. Now I always do my percentage questions using this triangle, final, original, multiplier. You just cover up the one that you want to find, and then that will give you the equation that you need. So here, final, well, I'm working backwards, aren't I? So I've been given the cost after the increase. So the final is 19.25. The original is what I'm trying to find, and the multiplier, it's a increase of 10%. So if I start with 100 and I add on 10, I've now got 110%, which as a multiplier is 1.1, isn't it? Okay, So I want the original, so let's cover that up, and that means my original is equal to final divided by multiplier. Original equals final divided by multiplier, which in this case is £19.25 divided by 1.1. This is a reverse percentage question, isn't it? If you do it a different way, 19.25 divided by 1.1 on my calculator comes out to be 17.5. This is in pounds and pence though, isn't it? So that's £17.50. Have to put that extra zero on if it's money, otherwise you lose an accuracy mark. So the answer is £17.50. Dev invests £1,500 for 2 years. The compound interest rate is 1.6% per year. Which calculation works out the total value after 2 years? Circle your answer. Okay, now we can use compound interest with the formula. Our final amount is our original amount times our multiplier raised to the power of, normally number of years, but it might be something else, depends on the problem. So in this case we're working out the final. The original value was £1,500. The multiplier is going to be, well, if you've got 100% and you add on 1.6%, then you've got 101.6%, which as a multiplier is 1.016. So it's going to be 1.016 to the power of the number of years, and the number of years is 2. So which one is that? It's that one there. For part B, Emma invests £1,500 for 2 years. The interest rate is 1.8% for the first year and 1.3% for the second year. Whose investment is worth more after 2 years? You must show your working. Okay, so 1.8 is going to be a multiplier of 1.018, similar to what we were doing a moment ago. And this one is going to be 1.013. So to work out this amount in the first year, we are going to be starting with £1,500 and we're going to be multiplying by 1.018, which gives us 1,500 times 1.018, sorry, it gives us 1,527. So that's what we've got at the end of the first year. In the second year, 1,527 is going to be multiplied by our second multiplier of 1.013, which gives me answer times 1.013, got 1,546, 1,546.85 rounded off. So which one was worth more? Oh, we didn't work out the first one, did we? Let's work out the first one. Whose investment was that? Dev's investment. So this is Emma's investment. Dev's investment was 1,500 times 1.016 squared. So 1,500 times 1.016 squared, that is 1,548.38. So we can see that Dev's is worth slightly more. Dev's. Question 6. £4,000 is invested at 1.5% compound interest. Show that the value of the investment after 2 years is £4,120 and 90 pence. Okay, with percentage questions I usually start off with my little remembering triangle, final, original, multiplier, to work out which way around it goes. So here I've been given the original which is £4,000. I know the multiplier. It's 1.5% interest. If I start with 100% and I add on 1.5%, I've got 101.5%, which as a multiplier is going to be 1.015. And the final is what I want to find, isn't it? Okay, so covering up the bit that I know or I've got is the final. So final is equal to original times multiplier. So in this case, it's 4,000 times 1.015. Now that would find one lot of 1.5% added. Now if I want to do compound interest, I raise that multiplier to the number of years or the number of times I'm going to apply it. So it's going to be 4,000 times 1.015 squared. Time to reach for the calculator again. 4,000 times 1.015 squared is £4,120.90 as required. Okay, in 6b, we're told that in the third year the interest rate falls to 1.4%, and in the fourth year the interest rate falls to 1.35%. And we're asked whether the interest in year 4 will be more or less than the interest in year 3. Okay, so let's first off rewrite those percentages as multipliers. Now, using the same sort of approach we did earlier, starting with 100% and adding on 1.4%, giving us 101%, which is 1.014 as a multiplier. And I'm going to have 1.0135 for that one. Okay, so then in year 3, we're going to start with what we had at the end of year 2, which was 4,120.90. So 4,120.90. I'm going to multiply through by our year 3 interest rate, which was 1.014. And on my calculator, I get 4,120.9 times. I make that £4,178.59. And then in year 4, I'm going to start with that £4,178.59. So we're going to multiply it through by 1.0135. And that is equal to, now I'm just going to carry on multiplying on my full calculator display. So to maintain accuracy, so that I make that £4,235 and no pence. Okay, now the question actually asked, will the interest for year 4 be more or less than the year 3 amount? We haven't worked that out yet, we've just worked out the totals, so we need to do that as well. So how much interest did we earn in year 3? Well, we started off with £4,120.90 and we ended up with £4,178.59. So taking one away from the other should tell us how much interest we earned during that year. So that's an increase of £57.69. And in year 4, the difference between that and the year 3 amount, 4235 minus 4178.59, I make that £56.41. So we made slightly more interest in year 3. So will the interest in year 4 be more or less than the interest in year 3? It will be less. Question 7. Investment A. Save £150 per month for 2 years. 2.5% interest is added to the total amount saved. Or we've got investment B. Invest £3,500. Compound interest is added at 3% per year. After 2 years, how much more is investment B worth than investment A? Okay, let's start with investment B then. Save £150 per month for 2 years, and 2.5% interest is added to the total amount saved. So if we're saving £150 per month for 2 years, then we've got 150 times 2 lots of 12 months, which is 24 months. What's that then? So 150 times 24, that comes out to be £3,600. Okay, slightly more than the investment B. And then 2.5% interest is added to the total amount saved. So using our final original multiplier triangle, we want to know our final amount, and that is going to be, well, if I put my thumb on F, then I can see it's original times multiplier. Okay, so F here is what we're trying to find. O is the original amount, which is 3,600. And the M, the multiplier, is a 2.5% increase, isn't it? So it's 102.5%, which as a multiplier is 1.025. So my amount then is going to be 3,600, my original, times my 1.025. And that is equal to times 1.025, that's 3,690. Sorry, that was investment A up there, wasn't it? I'm doing investment B now. I'll get it the right way around. So that was investment A, and now I'm doing investment B. So investment B is invest £3,500 compound interest for that's 3% per year. So again, using my triangle, F is equal to the amount I'm trying to find. The original this time is 3,500, and the multiplier is an increase of 3%, so that's 103% as a percentage increase, which is 1.03 as a multiplier. So then my final, this again is going to be my original times my multiplier. But because it is compound interest, I'm going to raise that to the power of the number of years that we're going to do it for. So that's going to be 3,500 times my 1.03 raised to the power of 2. Okay, tapping that into the calculator. 3,500 times 1.03 squared, which comes out to 3,713.15. 3713.15. Okay, so the question asked how much more is investment B worth than investment A? So I need to subtract one from the other now, don't I? So 3713.15 subtract 3690. So that's £23.15 more, isn't it? £23.15. Now you notice I'm using a new emulator, or a new calculator this time. I've switched over to the Casio FX83 GTX, which is the new Casio model. Very nice piece of kit, and if you haven't got a calculator yet already for your exams, then this would be the one to go for, I think. I'll put a link to my shop in the description below, so you can click on that to find all my recommendations for calculators and revision guides and things for your GCSEs. Okay, let's move on. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.